The car industry is in the middle of its biggest revolution in over 100 years. But this time, it's not about engine size or shiny chrome trim. It's about intelligence. Not just the AI that lives in the cloud, but something much more tangible. We're talking about physical AI, intelligence that can see, touch, and interact with the world around it. What if your next car was designed by an AI that ran 1 million simulations before a single piece of metal was stamped? What if it was then built with millimeter-perfect precision by a robot that learns from every task it performs? And what if that same car could then drive you home, navigating the chaos of city streets more safely than a human ever could? This isn't a far-off future. This is the world of physical AI, and it's happening right now, from the factory floor to the open road. Today, we're going to show you how intelligent robots aren't just building your car, but how your car itself is becoming one. The problem for the last century, making cars, has followed a familiar, rigid script: massive assembly lines, human repetition, and a one-size-fits-all approach. Innovation was slow and incremental. On the road, the story was much the same. The single biggest point of failure in any car has always been the person behind the wheel. An estimated 94% of all crashes are caused by human error. For decades, we've accepted these limitations: slower production, higher costs, and the tragic toll of human fallibility, as the cost of mobility. But that entire paradigm is being shattered. The solution: physical AI. The force behind this disruption is physical AI. So, what is it? Put simply, physical AI is where artificial intelligence gets a body. It's the fusion of intelligent software with physical systems, robots, sensors, and the vehicles themselves, allowing them to perceive their environment, reason about it, and act on it in real time. It's an ecosystem where machines learn and adapt from physical experience, not just from data on a spreadsheet. This revolution is unfolding on two massive fronts at once. First, inside the factories where cars are made, and second, inside the car itself, fundamentally changing the act of driving forever. Let's start where every car begins: the factory. The intelligent factory. The factories building our cars are becoming less like 20th century assembly lines and more like self-organizing, intelligent hives. This is where physical AI is making cars better, faster, and more efficiently than ever before. It all starts with design. Before a robot tightens a single bolt, a design AI is already at work. Engineers are using AI-powered simulation tools that can test thousands of design variations in a virtual environment. Software from companies like Ansys can combine predictive simulation with generative AI, shrinking the time it takes to validate new designs from days to minutes. Instead of building costly physical prototypes for endless crash tests, AI runs countless virtual ones, learning from each simulated impact to create vehicle structures that are lighter, stronger, and safer. These algorithms analyze complex data patterns to help engineers optimize everything from aerodynamics for better fuel efficiency to the structural integrity of an EV's battery pack. It's not just about making the same parts faster, it's about discovering entirely new designs a human might never have conceived. Once the design is locked, physical AI take over the factory floor. And we're not just talking about the simple robotic arms that have welded car bodies for decades. We are entering the era of the humanoid robot. In a groundbreaking move, BMW is partnering with robotics companies like Figure AI and Hexagon to pilot humanoid robots in its production lines in the US and Europe. A 2025 pilot at its Spartanburg plant, for instance, involved a robot called Figure 2 assisting in the production of over 30,000 vehicles by moving more than 90,000 sheet metal components. These aren't pre-programmed machines mindlessly repeating one task. They are adaptable colleagues that can be trained for various jobs, from handling parts to performing intricate assembly tasks. Chinese tech giant Xiaomi is also testing its own humanoid robots in its electric vehicle factory. In early 2026, the company announced its robots were successfully installing nuts on car chassis, keeping pace with an assembly line that produces a new car every 76 seconds and achieving a high success rate. This is physical AI in action, learning by doing. But it's not just humanoids. Companies like BMW and General Motors are creating digital twins of their entire factories using platforms like NVIDIA's Omniverse. They build a complete, photorealistic virtual replica of the production line where AI can simulate workflows, identify bottlenecks, and optimize processes before any physical changes are made. This allows them to coordinate the complex dance between humans and automated systems with incredible efficiency. BMW's AI-QX platform acts as a central nervous system for the factory, analyzing data from thousands of sensors in real time to detect errors and improve quality on the fly. The results are staggering, leading to significant reductions in deployment times and operational costs, all while reducing defects and waste. The car as a robot, the same physical AI that builds your car, is now also driving it. The modern vehicle is quickly evolving from a tool you operate into a partner that assists you, and eventually, a fully autonomous chauffeur. It's no longer just a collection of mechanical parts, it's a rolling, learning supercomputer. At the heart of this transformation is a simple but incredibly complex process: sense, plan, and act. Just like a human driver, an autonomous vehicle needs to perceive the world around it. It does this using a sophisticated suite of sensors. Cameras act as its eyes, radar provides the ability to see through rain and fog, and LiDAR builds a detailed, 3D map of its surroundings in real time. Physical AI is what takes this firehose of raw data and turns it into understanding. Companies like NVIDIA are at the forefront with their drive platforms, which are being adopted by a massive ecosystem of automakers including Mercedes-Benz, Volvo, and General Motors. These systems are the brains of the operation, using powerful AI models to process sensor data, identify pedestrians, predict the movements of other cars, and make split-second, human-like decisions. Peer-reviewed studies of Waymo's robotaxis have already demonstrated a remarkable safety record, showing significant reductions in crashes that result in injury compared to human drivers. This is the AI company Pilot, a system that never gets tired, never gets distracted, and reacts faster than any human ever could. We're currently in the era of Level 2 and Level 2++ systems, like Tesla's full self-driving and Mercedes-Benz's Drive Assist, which can manage steering and speed but still require an attentive driver. But here is where physical AI gets truly interesting. The car is not just a robot, it's a learning robot. Every mile driven by a vehicle in the fleet becomes data. That data is used to train and refine the central AI model, which is then sent back out to the entire fleet via over-the-air software updates. A tricky intersection navigated by one car in Phoenix can teach every other car in the network how to handle it better. This creates a powerful feedback loop where the entire system gets smarter and safer over time. Your car is a perpetual student, constantly improving based on the collective experience of millions of other vehicles. To ensure these systems are safe before they ever hit the road, companies are turning back to simulation. Using digital twin platforms, engineers create photorealistic virtual worlds to test the AI against millions of dangerous edge cases. A child running into the street, a truck braking suddenly in the rain, without any real-world risk. These false memories allow the AI to experience and learn from scenarios that might only happen once in a million miles of real driving. Implications and the future. So, what does this all mean for the future? The implications of this shift to physical AI are profound. In manufacturing, we are moving towards an era of mass customization. The flexible, intelligent factory can adapt on the fly, making it possible to build a car tailored to an individual's exact specifications without the massive costs of retooling. On the road, the biggest promise is safety. With AI company pilots and, eventually, fully autonomous systems, we have a clear path toward dramatically reducing the tens of thousands of deaths caused by human error on our roads each year. Convenience is another massive benefit. Imagine reclaiming the hours you spend stuck in traffic, free to work, relax, or connect with family. But this revolution isn't without its challenges. As auto manufacturers increasingly rely on the same powerful AI design tools, will all cars begin to look the same? If an AI determines one specific aerodynamic shape is most efficient, will we lose the diversity and artistry that has defined car design for a century? Furthermore, the path to full autonomy is paved with regulatory and ethical speed bumps. As of early 2026, nations are still grappling with creating unified legal frameworks for self-driving cars. Efforts like the UN's work on a global regulation aim to standardize safety, while in the US, proposed legislation like the Self-Drive Act of 2026 is attempting to create a national framework in a landscape currently dominated by state-level laws and federal guidelines. And there's the classic ethical dilemma. In an unavoidable accident, who does the car choose to protect? These are complex questions we must answer as we hand over more control to machines. From the digital drawing board to the intelligent factory, and from the AI company Pilot to the promise of a fully autonomous future, physical AI is rewriting the rules of the automotive world. It's a revolution on two fronts, transforming not only how our cars are made, but what a car is and what it can do. We are at the very beginning of this journey, witnessing the birth of a new kind of mobility, one that is smarter, safer, and more integrated with our lives. This transition from digital intelligence to physical, embodied AI is the single biggest leap forward for the industry in 100 years. The vehicle is no longer just a machine, it's becoming a partner. So what do you think? Are you excited to let an AI take the wheel, or do you have concerns about this robotic future? Let us know your thoughts in the comments below. And if you enjoyed this look into the future of automotive tech, be sure to like and subscribe for more on the tech that's changing our world.